Good morning, students. Today we're going to talk about congruence, and especially with triangles, congruence, but we can have congruence of any polygons, as we'll see coming up here. But our focus is on triangle congruence, and here we go. Congruence of shapes means that all the corresponding sides, plural, and corresponding angles are congruent. And we'll get into that here in just a second. Congruence has the basic idea of the same shape and size. So exactly the same. Where similar means the same shape, but not necessarily the same size. It could be bigger or smaller, but it's going to be the same shape. Based on this definition, congruent shapes also are similar. So a congruent shape would be a one-to-one similarity. It's similar, it could be 2-to-1, double the size, or 3-to-1, triple the size, or 4-to-3. Okay, whereas congruence would be a 1-to-1. Okay, so here we have triangle ABC is congruent to triangle DEF. This is called a congruent statement. A congruent statement is something being congruent to something else. It doesn't have to be an entire triangle. It could be an angle. It could be a side. But something is congruent to something else. It's called a congruent statement. You need to know that because they're going to ask you or say, write a congruent statement. So you have to know what it means to have a congruent statement. Something congruent to something else. All right, so here they tell me triangle ABC is congruent to triangle DEF. This means that angle A is congruent to angle D. That means I can go ahead and put my congruent marks on here. A is congruent to angle D. B, so since we already used 1, we use 2 now, is congruent to E. And C, 3 now. 1, 2, oops, that's ugly. 3, 1, 2, pretend these are little curves in there. 3. Okay, so now we've marked our corresponding angle. So A corresponds with D, B corresponds with E, and C corresponds with F. So when you saw up here that all the corresponding sides and corresponding angles, I just named off the corresponding angles, are congruent. So now the corresponding sides, we look right up here again at the congruent statement to get that. So AB, segment AB, I'll change the color here, is congruent to segment DE. So 1 hash mark each because we haven't used any yet. Segment BC, 2 hash marks since we already used 1, is congruent to EF, 2 here. And segment CA, the last one, 3 segments now. Let's make that a little longer. Is congruent to FD, 1, 2, 3. Okay, so this is all our markings that we can have for 2 triangles being congruent. Okay, so one of your questions is going to be on a quiz or test or both. Name all the corresponding parts of these 2 triangles. So you're going to have 3 corresponding sides, 1, 2, and 3, and 3 corresponding angles, 1, 2, and 3. For a total of 6 corresponding parts. So you better have 6 parts in your answer. 3 angles and 3 sides. For a total of 6, because those are dealing with triangles. If we had quadrilaterals, we'd have 4 sides and 4 angles for a total of 8. If we had pentagons, we'd have 5 angles and 5 sides for a total of 10 that we'd be having to write down. Okay, but you're just going to be dealing with triangles. Okay, but it can be with any number of polygons. All right. Make sure that you don't have any repeat arcs or hash marks. Okay, they're all different. We don't know that any of the sides are exactly the same as another, so we use different number of hash marks and arcs to represent that. All right, now for triangle to be congruent, all 6 pieces have to be congruent. Okay, and so if they already tell me that, then that tells me all 6 pieces, the corresponding parts, are congruent. All 6 of these parts are congruent. Well, we don't have to have all 6 given to us to know if the 2 triangles will be congruent. As it says, we don't have to show all 6 corresponding parts are congruent to know that the triangles are congruent. Here are ways that we can prove 2 triangles congruent by only showing 3 certain corresponding parts are congruent. So we have 5 ways to prove triangles congruent using just 3 of these 6. Okay, one is ASA, which tells you is angle, side, angle. Another is SSS, side, side, side. Another is SAS, side, angle, side. Another one is AAS, angle, angle, side. And the last one is HL, which is only for right triangles. That means hypotenuse and leg. Obviously, hypotenuse is only in a right triangle, so that makes sense. That's got to be in a right triangle here. So what I've done is I've drawn an example of one triangle. Normally, you'd have 2 triangles, which you'll see on the next page coming up, showing that they're congruent here. I've just drawn an example of one of each type right here. So here's angle, ASA, angle, side, angle. This middle letter is called inclusive. It is included between the 2 angles. Included is a key word. Sometimes they'll ask that on the park or on a question. What is the included side or angle? The included one is the middle one. Okay. Here we had SSS. I don't know what happened to. Okay, maybe I covered it up. SSS. Side, side, side. Very easy. Okay. Here we have SAS. SAS. So the included piece here is the angle. The middle one is the angle is included between the 2 sides. The trickiest one is AAS. Notice I've drawn 2 examples for that because it's tricky. And these are not the same. Both these are AAS, but these are different examples of AAS. So you notice we have AAS here, and here we have AAS here. The difference is this S is next to the side with 2 arcs, and this S over here is next to the side with 1 arc. So they're not the same. If this hash mark would have been here, next to 2 arcs, then those 2 would have been exactly the same. But this one is next to the 1 arc. This one is next to the 2 arcs. So if this was the question, it had these 2 triangles drawn. I see AAS, AAS. Are these congruent? The answer is no. Okay, because this S is on the wrong side. It had to be over here with the 2, or this one would have to be over here with the 1 to make them congruent. Okay, so that's a tricky one to make sure you're paying attention to when you see that in your problems. Last one is HL, hypotenuse leg. So remember, it has to be a right triangle, and then we have a hypotenuse and one of the legs. It doesn't matter which one. I just chose that one. It could have been this one as well. Okay. All right, so now let's go ahead and look at examples. First, so now I've put in this page I got from a book that has both 2 pairs, or 1 pair of each type. So you have SSS, SAS, ASA, ASA. So these are congruent. So notice here's my triangle congruent statement on it. Here we have AAS, AAS. Notice on this, the S's are both next to the 1 arcs. Otherwise, they'd have to both be next to the 2 arcs, like I showed you in the other page, previous page here. And lastly, hypotenuse leg. Got to be in a right triangle, and you have the hypotenuse and one of the legs. Okay. So notice we only needed 3 pieces. So if we can show any of these situations to be true, then the entire triangle is congruent, which means the other pieces that we haven't identified yet, we can now mark in there. Okay, so I'd now be able to say that angle B is congruent to angle E. Now, there's 2 ways to figure out that B corresponds with E. I can look either at the hash marks here, and B is between the hash marks of 2 and 1, so it has to be the same one as between 2 and 1, which is E. This C is between 3 and 1, so it corresponds with between 3 and 1, which is F. And D, which is between 2 and 3, has to be between the 2 and 3 over here, A. That's one way from looking at the drawing to match up the corresponding pieces, or angles themselves. The other is to look at the congruent statement. A corresponds with D, B to E, and C to F. Okay, but if you didn't have this given to you, that's how I would go about doing it. Between 1 and 2, between 1 and 2, between 1 and 3, between 1 and 3, between 3 and 2, between 3 and 2. Those are corresponding angles. And then you could write that congruent statement itself. Okay. All right. So now let's go ahead and look at some examples here. It says complete each congruent statement. Notice they give me the congruent statement for the entire triangle. They're only now wanting 1 piece, which notice is a side. So it says segment EF right here. Obviously, that's going to correspond with XZ. So we type in XZ, and it has to be a segment. If you forget your segment bar, you get no credit. We've talked about this. You can't forget your symbols. Now, angle M, I look up here in angle M. M corresponds with Q. So I'd have an angle symbol. Let's grab the angle only. Angle Q. Capital letters, remember? You're using capital letters all the way. Okay, angle F. Angle F over here. First one corresponds to the first one over here. Angle A. Oops, undo. I forgot to copy this first. Copy. I can put that in there. So F corresponds with A. Okay, now we're back to a side again. Side ST corresponds with side XY. It's a segment, so I have to have a segment bar above it. It should be easy. You're going to get a worksheet doing all this yourself. I'm just giving you examples right here. Complete each congruent statement. So again, it's the same idea. Angle Q. Now they don't give me the triangle congruence. They just give me the drawings. I have to get it from the drawings this time. Angle Q. Notice one arc. I look over here. Which one has one arc? Angle U. Very simple. It's got to be the same one. So angle U. Okay, segment AB. Segment AB, notice it has one hash mark. So I look over here, which one has the one hash mark? Now, what I need to do is I need to put in what's called corresponding order. Since they call it AB here, A started with the two arcs and went to the right angle. So I have to start with the two arcs over here, go to the right angle. So it has to be ED, segment ED. I cannot call it DE from now on. You have to put it in corresponding order. I talked about that in a previous video about corresponding order. Now you're seeing what I'm talking about. So if you put DE, you get marked wrong. It has to be in order. Since it went from two arcs to the right angle, it has to go from the two arcs to the right angle over here. That's what's called corresponding order. All right, so here again, HI, segment HI right here. 3 hash marks. So I go over here, 3 hash marks. Now again, I have to check the order. It went from H to I, 1 to 2. So I have to go 1 to 2. Notice it's 1 to 2. So it's FE over here. Segment FE. Don't get burned and call it EF. Just because you, oh, let's see, it looks like they match up. No, they don't. 1 goes to 1 and 2 goes to 2 over here. Don't get caught on that. That's a common error students make who want to rush through it or who don't pay attention to detail. All right, lastly, angle X. I look at angle X, it has 3 arcs. So I look over here, which one has 3 arcs? P, angle P. And there's my answer. You see, this is not very hard. And if triangle QRS and BCD are congruent, so that's like if they wrote this out like this down here, what's the corresponding part to SQ? So SQ, 3 to 1, I go D to B, 3 to 1. So it has to be in corresponding order, so I have to say segment DB. If I say BD, I get wrong, marked wrong. Okay, DB, there you go. All right, so there's that page done. Let's go to this one now. Some more. So notice when ABC, right angle to B is 2 arcs to 1 arc. So right angle, 2 arcs, 1 arc. So I have to go right angle, 2 arcs, 1 arc. DEF. Okay, has to be my answer. So DEF, and I need to put that triangle in front of it here. Triangle DEF. Okay. So now we're doing entire triangles for our congruence. Instead of a side or an angle like we did on the last page, it's the entire triangle congruent. So what's the order here? UVW, UVW. They went 2, 1, 3. So I must go 2, 1, 3. 2, 1, 3. X, Y, Z. All capital letters or you're wrong. No lowercase. All right, here they went PQR. 3, 2, 1. So I have to go 3, 2, 1. STR. Okay, can't go RST. Can't think PQR. Oh, they went alphabetical here, so I'll just go RST. No, I have to look at P is 3, S is 3, Q is 2, T is 2, Q to T, and 1 to 1. Okay, R here and R here. Corresponding order, that's called. All right, KLM. They went 3, 2, 1, so I must go 3, 2, 1. FGE. Okay, here we go. DEF. DEF is 1, 2, 3. So we go X, Y, Z. 1, 2, 3. Same thing. Practice it over and over again. It should be easy now when you see it, when you do your own. Shouldn't even have to have me explain anything. It's all right here in the video. X, Y, Z. Nice and easy. TUV. TUV is 1, 2, 3. So I must go 1, 2, 3 here. 1, 2, 3. WXV. WXV. All right, here, JKL, JKL, they went 2 right angle 1. So I must go 2 right angle 1. NML. NML. Okay, lastly, CDE. CDE here is 1, 2, 3. So I must go 1, 2, 3. FED. That's called putting things in corresponding order. And that's how you have to do it on the park. FED. If you put it in wrong order, even though it's the same thing, you don't get any credit. Same as I grade it on your quiz or test as well. All right, next, we're going to identify whether there's enough information to tell if these two triangles are congruent by one of these 5 ways. And if so, we name the 5 ways. And if I have to put another mark on the drawing, I will. So, 2 key things to remember here. That's going to help you out big time. They'll make it easy for you. Okay? If they share a side, so they're connected. See how these two triangles are connected? They share a side. These 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 share a side. You're going to have a side in common, and therefore the side is congruent to itself. So I can put on a hash mark. Well, the one's already being used, so I go up to 2. This side is congruent to this side in both the triangles. So I have that piece, and that is called reflexive property of congruence. Reflexive property of congruence. This is one of your justifications. Remember, we talked about justification before in our angle, our worksheet we did with triangles. Well, here's another one, reflexive property of congruence. Very common in all proofs. They often have these type of drawings. These are going to be the same you're going to see in the park. Possibly one of these. And that answer is reflexive property of congruence when you do it in a proof, in a 2-column proof that will be coming up next. Not this unit, or not today, but the next class. This will be one of your justifications when we set that side equal to itself. Okay. So now I look, do I have one of these setups here? I look here and I see I have an S and an A and A, but notice when I have two S's and an A. The only one that has 2 S's and an A is this one, SAS. But where does that A have to be? It has to be between the 2 sides. Here's the 2 sides, it has to be between it. It has to be right there. Do we have an arc right there? No, we don't. So therefore, there is not enough information to do anything with this. So any I for not enough information. Any I says for not enough information. So we do not know. We don't have enough to go by to see if these two are congruent. Okay, next one. Again, we share a side, so we can automatically put on our congruent statement, a reflexive property, and our hash mark there. And notice we have ASA and ASA. So there's our answer right there, ASA. So I just write down ASA. But I want you, anytime you can, you put a marking on there itself if it's not there. Again, I see I have share side, so I immediately put that on there. And when I ask you in class, what's my justification for that? You're going to tell me reflex or property of congruence every time. I'm going to ask you that over and over until it's pounding in your head. That's going to be on your proofs on the part test as well. Okay, so now what do I have here? Okay, well, the first thing I want to ask myself, I see I have a right angle here. Remember, I have a right triangle. I want to first ask myself, does the HL theorem, hypotenuse leg, work? Is it a right triangle? It may not. But that's the first one I want to check. Right triangle, what is this side called? It's the hypotenuse. How do I know it's the hypotenuse? It's opposite that right angle. And that's a leg, and that's a leg. So I have the hypotenuse leg here, and I have the hypotenuse leg on this one. So this is true by the HL theorem. Okay, so we go to this one again, we share side. So we put hash marks. Well, they've already used 2 and 3, so I can just use 1 right there. And why do I know that's true? Reflects our property of congruence. So now I have SSS. Very easy to see right there. Okay, now when they are connected, they don't share side, they're connected. The first thing I'm going to look for is vertical angle theorem. Notice I have vertical angles right there. So 2 arcs. So 2 arcs. Okay. And now that I have that in there, I see ASA, ASA right there. So now I have angle side angle. Oops, did I get the right letter on the keyboard here? ASA. Number 12. I have a right angle there. Sometimes I can draw my other right angle here. I know that's going to be a right angle. And don't forget they share side. So I put my 2 hash marks here because one's already been used. And my justification is what? Reflects the property of congruence for that. And notice I have a right triangle again. And what is that side called? The hypotenuse. And there's a leg. So HL. HL. So hypotenuse leg again for that one. Okay, we come over here. We only have 2 pieces given. So there's nothing besides HL. That's 2 pieces, but it's got to be right triangle. It's not. So again, NEI here. Not enough information. Here we see we have vertical angle theorem. Trying to get getting the pattern here. These are the 2 main ones that you're looking for. Either vertical angle theorem there, or if they share a side, reflects the property of congruence. They are used heavily in your proofs. Don't forget these. Next class, we'll do proofs. These will be our justifications. So again, that's vertical angle theorem. I didn't write it last time. You don't have to write it here. I'm just pointing it out to you so you see it. Okay, what you have to do is you have to put your 2 arcs and 2 arcs. And then I notice I have, even though it's a right triangle, I don't have the hypotenuse, right? So I can't use HL, but I do have ASA. ASA. So my answer is ASA. It must be the same in both triangles, ASA, ASA. I can't have ASA in one and SAS in the other. That's not legal. It's got to be the exact same one twice. Okay, here we have a right triangle. Well, let's first put on our given piece here. Our reflexive property of congruence that shares that side in both triangles. And now I see I have a right triangle. There's my hypotenuse here and a leg. Here my right triangle, hypotenuse and a leg. So HL theorem again right here. Okay, here we look, you see we have SAS. Here we do not have SAS. That A should have been right there if it was SAS. Remember, the A has to be in between the included piece. SAS is not there. So that's not enough information. Okay. Here we can see we have SSS. That's clear as can be. Easy. Okay, here we have SAS and SAS. So we have SAS. Notice it's not HL, even though it's a right triangle, because we do not have the hypotenuse. Remember, here's the hypotenuse here. That's not marked. And here's the hypotenuse here. That's not marked. So it's not HL. Just because it's right angle, it doesn't mean it's HL at all. This one is SAS. Okay, we go here. We should see vertical angles immediately. That should just be a dead giveaway by now. We've done so many vertical angles. Okay, immediately draw that in there. And now I see I have SAS, SAS. By the way, when you look at the SAS and the SAS, they have to have the same number of hash marks. So 2 to 2 and 3 to 3. If that had 1 hash mark and that had 3 and that had 2 and 3, it would not be congruent. It has to be the same number, 2 to 2, 3 to 3, and then you're in between. So that is SAS. Okay, so you have to pay attention to little things like that. And lastly, oh, right there, sharing a side automatically. Put my hash mark on it. 1 says 2 and 3 have already been used. And now I have SSS. Easy right there. Okay. Now, as it says, I want you to pause the video and do these ones on your own. Okay, when you're done, press play to see the results. If there's, like on the last page, if there's not information to tell, you write NEI like I did on the last page. So go ahead and pause the video. Hey, I said pause the video. Pause it. All right. Okay, you're back. All right. So notice I didn't put the answers on this page. I put them on the next page here. So now you can check your answers. See if you got them right. And if you don't understand why one of these is here that I have down as an answer, you didn't get that answer and you can't go back and figure out why it's here. Because if you don't understand one more of these answers up here, come see me during EL and ask about it if there's one or more them, if there's plural of them. Okay, because then I'm just going to go ahead and give you your worksheet and you can get started on it right in class of doing what you just did on these pages right from the get-go. All right, that ends this video.